Hello friends, in this video we are going to write a program for 8051 microcontroller using its assembly language to transfer a block of n bytes from the source to the destination location. So in this program we have to transfer the block of n bytes. Suppose there are 10 numbers which are stored at some memory location. So we have to transfer those 10 numbers from the source memory location to the destination memory location. So here in this video we will see that how we can transfer these bytes and what instructions are used in the program. So let's start with our video. So we have to transfer a block of n bytes from the source to the destination memory location, and this is called the overlapped block transfer. Overlapped block transfer means that the source and the destination memory location, they are overlapping each other. So some of the data of the source memory location, it will be overlapped by the destination memory location when it is transferred. So first of all, let us see the program statement for this. So we have to write an assembly language program using the instructions of 8051 microcontroller. Okay. And this program is to move a block of n bytes of data from source to the destination. Now here we have to assume that the length of the block which is at the source memory location, the length of that block is stored in register R2 of register bank 0. In the 8051 microcontroller, we are having 4 register banks. Bank 0, 1, 2 and 3. There are 4 register banks. Now in these register banks, each register bank is having 8 registers from R0 to R7. Now these registers can be used to store the data in the programs. Okay, so if we want to use the registers of any of these register banks, first of all we have to select that register bank. Now it is given to us in the question that the length of that block is stored in register R2 of register bank 0. So we have to select this bank 0, and then the register number R2 of that bank 0 is storing the length of the source. Because it is written that we have to transfer a block of n bytes. Now how many numbers are stored at that source memory location? Suppose 10 numbers are stored, or 20 numbers are stored, 30, 40. So how many numbers are stored at that is the length of that block is stored in register R2. So let us suppose that the length of that source is n, and n is equal to 10. Okay, we are supposing that there are 10 numbers and we have to transfer those 10 numbers from one memory location to another memory location. Now the source memory location, what else we need in this program? the source memory location, that where those 10 numbers are stored, and also the destination memory location, that where we have to transfer those 10 numbers. So in the question it is given to us that the source block, it is starts from the memory location 20H, and the destination block, it is starts from the memory location 25H. So here the source memory location starting address is given 20H, and destination memory location starting address is given to us 25H. Now there are 10 numbers. So 10 numbers means 20, 21, 22, 23, 24, 25, 26, 27, 28 and 29. These will be 10 memory locations. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 memory locations. Now these 10 memory location is having those 10 numbers. Now from 25H, 25, 26, 27, 28, 29, to A, to B, to C, to D, to E, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are again 10 memory locations. So the numbers which are stored at 20 to 29, they will be stored at from 25 to 2E. Now you can see that 25 is coming in this address also and here also. So whatever data will be there, when we are transferring that data from 20H to 25, it means overlapping is being done. Okay, so 25 to 29 memory location, they are common in these two. So the block transfer is called the overlapped block transfer. Okay, that is why in the heading I have written that it is an overlapped block transfer. It is not just like that 10 memory locations are different and if we are transferring like that, like from 20 to 29, okay, and from 30 to 39. Suppose if that the destination memory location, its starting address is 30, then there will be no overlapping. 20 and 20 to 29 will be different and 30 to 39 will be different. Okay, so no overlapping is there. But here because 20 to 29 and 25 to 2E, there are these memory locations are common in these two, so there is an overlapped block transfer. Okay. So this is our question and for that we have to write the program. So let us first see that what logic we are going to use to write this program. So first of all, because we are given that the block of n bytes is given, and the length of this block of n bytes, that is n value, which is equal to, we have assumed that n is equal to 10, that is stored in register R2 of register bank 0. So first of all, because as I have said that there are 4 register banks, and if we want to select any register bank, there is a program status word PSW in the 8051 microcontroller. So in this program status word, there are 2 bits, the third and the fourth bit, which decides that which register bank is to be select. So these two are used to select the register bank. Suppose that these two bits are 0, 0, then bank 0 is selected, 0, 1, 1, 0 and 1, 1. So in this way, bank 0, bank 2 and bank 3, these 4 banks are selected. So if you want to select bank 0, these 2 bits are to be 0, 0. Then only the bank 0 will be selected and we can use the R2 register of this bank. Okay. So our first step will be to select the bank 0. Okay. So we will clear the bits of the PSW, the third and the fourth bit, and we will make them 0 so that this bank is selected and we can use the register R2. Now this register R2 is storing the length of that block. Okay, so first next step is to initialize this R2 register with the count, that there are 10 numbers and we want to shift those 10 numbers, transfer them from the source to the destination. Second, because we are having two memory locations, 20H and 25H. So to store these two memory location, we want two registers. We will use R0 register and R1 register and initialize them with the source and destination. Okay, we are going to initialize the R0 and R1 with the source and the destination address of the last element in the block. Last element means that R0 first we will shift in R0 the value 20. In R1 we will shift the value 25. Okay, then we will tell that source is having 10 numbers, so add 10 in this, it will get the value 29, and then add 10 in this destination also, so next R1 is going to have the value 2e. So R0 and R1, they will be initialized with the addresses of the last element of the source and the destination. Okay, after that we will transfer the byte, transfer that data block byte by byte, means one by one we are going to transfer the data block from the source memory location to the destination. Next, we will decrement the count, because when we have transferred one number, after that we have to decrement the count, that one number is being transferred. Now remaining are the 9 numbers. Then the second number will be transferred. Then we will decrement the count, that 2 numbers are being transferred and remaining are the 8 numbers. Then third number, fourth number, fifth number. In this way, all the 10 numbers will be transferred. So after every transfer, we have to decrement the count to tell the microcontroller that how many numbers are being already transferred and how many are remaining. After that, when first time we have decrement the count, after that we have to decrement the source and the destination addresses also, so that the transfer should take place at the next memory location. So decrement source and destination pointers. So first the pointers were, because they were initialized at the addresses of the last element, so now it will be 28 and it will be 2D. Now the transfer will be the number which is at 28, it will now come at 2D. The number which is at 27, it will now come at 2C. Okay, so in this way the transfer is taking place. After that, because we are decrement the count after every transfer, so we have to check that whether this count has become 0 or not. If not 0, repeat the process. Else, if it is 0, then stop, means end the program. Okay, So this logic we are using for transferring the data. Okay, how we are selecting the register banks, then how we are getting that there are 10 numbers, and then how we are initializing the counters and decrementing them and transferring the data. Now, before writing any program, first write all the steps, okay, that and create the logic that how you are implementing the program. After that, draw the flow chart of the program. Drawing the flow chart make it easy to get that what will be the sequence of the instruction, how the instructions are being written in the program. Because once you have drawn the flow chart, your next step will be just to replace the blocks of the flow chart with the instructions. Okay, so it becomes easy to write the program if you have drawn your flow chart. So first we will draw the flow chart for this program. In flow chart, the first block is the start block and it is drawn in the oval shape. Okay, after start, you can see that in the steps, our first step was to initialize the memory pointers R0 and R1 registers, and also initializing the count value in the R2 register. That means 10 numbers we are transferring. So initialization will be our first step. Initialize memory pointer 1 and initialize memory pointer 2. Because for source we need a different memory pointer, for destination we will need different memory pointer. So memory pointer 1 will be our R0 register and memory pointer 2 will be our R1 register. After that we have to initialize our counter, that there are 10 numbers. Now in the question it was written that the length of that block is stored in register R2. Okay, so the user need to store that value into the register R2, and microcontroller has to read that value from the register R2. Okay, so initialize the counter, or we can say that read the counter. Read it from the R2 register. This value is already stored in the R2 register. Okay. Next, from the memory pointer 1, we have to pick the data and we have to store that data at the memory pointer 2. So next step will be load data using memory pointer 1 and store data using memory pointer 2. Okay. After that, we have to decrement these pointers. So memory pointer 1 will be, now new will be memory pointer 1 minus 1. So we have to decrement the pointers. So we are decrementing it by 1. Okay, minus 1 will be there. Now memory pointer 2 is also going to be decremented. Memory pointer 2 is memory pointer 2 minus 1. That will become the new memory pointer. Now when we have decremented these two memory pointers, we have to, because one number is already transferred, we have to decrement the count also here, that one number is transferred, remaining are the 9 numbers. So next step will be to decrement the count. Just whatever steps we have written there, we are just converting them in the flow chart so that we can see that what will be the direction of flow or direction of flow of data. Decrement the count. So new count will be count equals to count minus 1. Then after that, check that whether the counter is 0 or not. So if here we are to make a decision, that is why it is shown in a diamond shape. Here we will check that is count equals to 0 or not. There can be two conditions, whether yes or whether no. That whether the count has become 0. If it has become 0, then we have to stop our program, end the program, again shown in the oval shape. If it is not, then we have to repeat the data, repeat those steps. So again the data will be loaded, again storing will be done, memory pointers will be decremented, count will be decremented, again it is checked that whether the count has become 0 or not. So these steps are repeated again and again until the count has become 0. When it is 0, then end the program. Okay. So this is the flow chart showing the direction in it. Okay. Now we will write the program. We have to use the instructions from the instruction set of 8051 microcontroller. Now, as I have said in the steps that the counter value is stored in the R2 register of register bank 0, and we have to first of all select this bank, and for selection of this bank we have to make the third and the fourth bit as 00. So in the program, we will write the first instruction to clear these third and the fourth bit. For clearing, we are having the instruction CLR. This instruction and the bits we want to clear. So we want to clear the third and the fourth bit of PSW, that is program status word. So we are writing the clear instruction that clear the third bit of PSW, clear the fourth bit of PSW. So these two instructions are going to select the register bank 0. So now we can use any of the 8 registers of this register bank from R0 to R7. Now next we are using R0 register for initializing the source address. Okay, in the question it is given to us that the source block starts from the memory location 20H and the destination block it starts from 25H. So R0 will be initialized with the address 20H, and R1 again of register bank 0, R1 is initialized with the address 25H. H means that these numbers are in the hexadecimal notation. Okay, and this asterisk sign is used to indicate that we are using the immediate addressing. Immediate addressing means that the number which is written after this sign, that is to be shifted in the register. So R0 is going to carry the data 20 and R1 is going to carry the data 25. So this data is directly shifted or copied into the registers. After that, because in R2 register we are having the length of the block, that is 10. Okay, so 10 numbers are there, and in hexadecimal notation it is written as 0A. Okay, so here because this is in R2, so we have to shift it is in accumulator, that is A register. So next step is move A and the register R2. That is the in register R2 we are having 10, so in accumulator this 10 number will be copied. Okay. Now after that, because we want to know that from 20 and 25, 10 numbers are stored, that at 20 to 29 and 25 to 2E. There are 10 numbers. So we have to add 10 in this 20 also and 10 in this 25 also. So what we will do, we will add A and R naught. So R naught is 20, A is 0A, and the addition of these two, that is 20 plus 0A, that means 29, is stored in accumulator. These two numbers are added and result will go in the accumulator. Now accumulator is having 29. So now this 29 should be shifted in R naught. R naught should carry 29. So next step will be move A into R naught. A is the source, R naught will be the destination. A will be shifted into the R naught register. Now this A, again we have to carry this 0A and add it in the R1 register. So again this step, that is R2, is to be shifted in A. Again A is going to carry 0A, because at this present time A is having 29. Okay, when we are moving any contents, it doesn't mean that the source has removed those contents. It has just copied those contents from the source to the memory location, to the destination memory location. Just copy is done, no removal or the erasing of the data is there. So again A is going to carry 0A. Now this is to be added with R1. So add A with R1. R1 is having 25. So 25 and 0A, they will be added. The result is 2E. So 2E is there, is now in accumulator. Now this 2E is to be shifted in the R1 register again. So again we are going to move A into R1. So R1 is now having 2E. Okay. Now and R naught is having 29. R2 is having 0A. So what we have done up till now, we have told the microcontroller that the source is starting from 20H, destination is starting from 25. You have to copy 10 numbers from source to destination. You have to transfer 10 numbers, and when you are transferring, then if you add 10 numbers from 20, these are from 20 to 29, and when you transfer them to destination, the last address will be from 25 to 2E. So these instructions has done. Up till now we have done this. Now transferring will be done. Okay, that how the data will be transferred from this memory location 20 to 20, 21, 22, 23, 24, 25. The number which is at 29, it is to be transferred to 2E. So what we have done, we have just moved the data into the source and the destination memory location addresses into the R0 and the R1 register. Now when we have added, R0 was first initialized as 20. When we have added 10 in it, it has become 2A. Okay, and when we have added in 25, when we have added 10, it will become 2F. Okay, but the numbers are to be stored between 20 to 29 and 25 to 2E. That will be the 10 numbers. But when we add 10, we will get 2A and 2F. So we have to decrement it by 1 so that it will become 29 and it will become 2E. Okay. So in the program, when we have added You have seen that we have added 10 in the 20, so it has become 2a, and when we have added 10 in 25, it has become 2f. Okay, but we have to decrement it by 1. So the next step here will be the decrement of R0 and decrementing the R1 registers. Okay, so now the R0 will become 29 and R1 will become 2e. Okay, that thing you have to keep in mind. Now, when it has become 29 and 2e, then transfer is to be done, that whatever data is there at 29, that is to be copied at 2e. So next step will be, first we will move that data which is at R0, the address which is in R0, at that we are having the data. So indirect addressing is used. That data is to be moved into the accumulator. Okay, because it directly we cannot move the data between the memory locations. We have to first move it into an accumulator, and then accumulator is going to be moved into that destination memory location. So next step will be to move the data which is in accumulator at the address which is in R1, that is at 2e. So first number is copied. Okay, now when this is copied, then again we will decrement R0 and decrement the R1. So now R0 will come at 28 and R1 will come at 2d. Okay, now when this has come, because one number is already transmitted, so the count that is in R2, that is 10 numbers are to be transferred, so it has to be decrement by 1. So next step is that decrement this counter and check that whether it has become 0 or not. So next step will be decrement and jump when it is not equal to 0. That is, D is for decrementing, J is for jump, and Z is for not 0. Okay, and what is not equal to 0? R2, you have to decrement R2 and check whether it is 0 or not. If it is not 0, then you have to jump to some memory location. Now, where it is going to jump? At the L1 memory address. Okay, and L1 memory address is the address where this instruction move a comma R0 is written. Okay, because when it is not 0, next step will be the number which is in 28, that is to be shifted in accumulator, and accumulator is stored at the next location. Again, R0 is decremented, R1 is decremented, number is shifted in accumulator, and then it is copied into the next memory location. Again, in this way the procedure is to be repeated until and unless the last number is being shifted and the count has become 0. Okay, so repeat this process until and unless this count value R2 has become 0 or not. When it has become 0, then you have to end the program. End is the last statement of every program of the 8051 microcontroller. It is going to terminate the program and show us the result. So the result will be shown at the memory location 25 to 2e. Let's take an example. Suppose that the source, we know that it is starting from 20, 21, 22, these are the memory locations. Okay, so before execution, the numbers are stored at the location from 20 to 29. What are the numbers? 01, 02, 03, 04, 05, 06, 07, 08, 09, 0A. These are the numbers. Now when the program is executed, so after execution, what will be the new data? The number which is at 29, okay, that will go to the memory location 2E, okay. So 2E is going to have 0A, 0, 9, 0, 8, 0, 7, 0, 6, 0, 5, 0, 4, 0, 3, 0, 2 and 0, 1. The remaining data will be as it is. So what it has done, from 2E to 2F, all the numbers are being, sorry, from 2E to 25, all the numbers are transferred, and from 20 to 29. So overlapping is there. You can see that the memory location 25 to 29, their data has been changed. Okay, and remaining data is also changed. Okay, so overlapping is there and remaining data from 20 to 24, it's remain as it is. So this is called an overlapped block transfer. Okay, so let us again see that how we have done this. So our first step is to initialize our count, that how many numbers are there in the block of n bytes, whether there are 10 numbers, 20 numbers. So that is to be initialized, given in the R2 register. That is already stored in it. Then R0 and R1 is the source and the destination memory location addresses. First of all, we have to select the register bank 0. So we are clearing the third and the fourth bit of the program status word. Then R0 and R1, we have shifted the source and the destination starting memory location address. After that, R2 is the length of the array, that is to be shifted in accumulator, and that number is added with R2, R0 also and R1 also. Now when it is added with R0, it will become 2A, and when it is added with R2, it becomes 2F. Now number is to be shifted from 20 to 29 and from 25 to 2E. Okay, but we have got 2A and 2F, so we are decrementing it, both the R0 and R1. After that, shifting is done. First the number is transferred into accumulator, and then accumulator is stored at the destination location. Both the R0 and R1 memory pointers are decremented, counter is decremented, and check that whether the counter is 0 or not. If it is 0, then end the program. If it is not 0, then repeat the process. So this is the assembly language program using the instructions of the 8051 microcontroller to transfer the block of n bytes from source to destination, that is the overlapped block transfer. So I hope that this program is now clear to you. Thank you.